Well, I'm going to actually kick things off here, and then I'll hand it over to Daniel and Luan to take over after a few slides. So I saw a couple comments in chat. Yeah, we do have the perfSONAR 5.0 logo here. We can thank Mark Veit for that. I think I use this joke probably too often. He's our marketing department, and so he does a great job with all the logos and all that stuff. So yeah, I think Daniel, you can go to the next slide. So I'm just going to talk really briefly to do some intro stuff, and then Luan and Daniel can kind of get into the meat of what we want to show and actually demo some things, because that's always more interesting than slides. But for those of you that have followed the project for a long time, you'll know we don't bump that first version number very often. I think the last time we did it, when we went to 4.0, that was about 5 years ago. That was when we introduced the pScheduler component, which is a huge shift for us. At one point, we were, thinking we would stick with the 4.x line, but obviously, as we got into thinking about kind of these archiving changes and things like that, it seemed significant enough that it was probably appropriate to bump that first number and call it 5.0. Plus, it gives us a chance to do that logo. So, lots of things aligned well there. And so a lot of things are actually going to go into perfSONAR 5.0. This talk is really mainly going to focus on that archiving and Elasticsearch, because that's probably by far that's by far the biggest change. There'll also be some great stuff going into pScheduler and our other components and things like that. But we're going to mainly stay focused on the kind of archiving and Elastic side of things today. So next slide. So just to kind of rehash what I showed you real quickly a few minutes ago. So the common workflow for perfSONAR is kind of mad dash and these grids like this. And, you can see these patterns like I talked about earlier, where, okay, there's this packet loss that between ESNet and ANL, and you can click on it. And next slide, Daniel. And then you kind of get these graphs, right? And as I talked about, it's like, okay, well, we can see something is going on in one direction that isn't going on in the other. And it looks like it's, the throughput's dropped, and it looks like it's related to packet loss, and there's some latency jumping around and things like that. And if you've debugged stuff like this a long time, maybe you have some idea of some things to check for, like that latency might be, some routing either flapping or something like ECMP, and maybe you've got a bad link or something like that going on. But can we go next slide? But whatever even you think it might be, or if you have some idea, or if you have no idea, oftentimes you're going to reach a point where you need to look beyond just the active measurements that perfSONAR can give you, and look at some of the other network data you may or may not have available. So I think common things are, interface stats from, technologies like SNMP, or if you're far enough along, you have some streaming telemetry going, that could be as well. Or, flow data to kind of break things down a little bit more if you need to, or maybe even you have to go to the optical level. And sometimes, I know kind of a common thing that happens with us is, okay, you see graphs like we saw in the last slide. Maybe you want to click through on that graph and see the trace routes that perfSONAR runs as well. That gives you a set of IP addresses. If you're able to map those to interfaces on your network, you can look at interface counters and errors and discards and things like that. And sometimes that can get you closer. But these are all kind of hard problems, right? And there's a lot of different groups that are looking at various ways to do this. But as we took a step back as a perfSONAR team and looked at kind of the entire landscape, we thought there was maybe a few things we could do to make this type of integration at least easier, even if we couldn't solve all those problems. And what that really boils down to is storing the data, and not just switching technologies on the back end, but kind of opening up the door to add new like metadata and things like that, so we can establish some of these relationships between the different data sources. And open up some new possibilities in that way. So Daniel, can you do next slide? Okay, and so what do we mean by archive? Again, I showed this diagram earlier, but just to kind of zoom back in. So the archive is a term we use in perfSONAR just to mean the thing we store measurements in. And as I mentioned, we've been using this thing called Desmond for quite a while. So pScheduler has a bunch of different plugins. It's long been able to write to more than just Desmond for archiving things, but that's kind of the default that most people use, because when you do install perfSONAR toolkit or similar, that's basically the default setup that you get, right? And then ultimately that's where the visualizations or analysis systems get what they're able to show. Next slide. So what is Desmond and kind of what does that look like internally? So as I already mentioned, it's the default archive for most users. Underneath the hood, it uses the Django framework in Python and has this custom REST API for getting at the data. Even further below that, it's essentially got two databases behind it. One is Postgres, which stores what we call the metadata, which is mainly just details about the measurement. So what's the source, what's the destination, how long are you running it, how often, any other test parameters you've given it. And then we actually keep the measurement results themselves in a Cassandra database. So this is like the TimeSeries data, so the timestamp, and then whether it's a number or a JSON blob or whatever, basically the time series of the measurements that we're seeing. And so this was developed a long time ago. Initially, it's a few generations ago of ESNet's SNMP system is how it was born out of. That's why ES are the first initials there. And so, the landscape has changed a lot since this was developed. And I'm not necessarily here to defend the two database system anymore that's behind it, because there's a lot of different ways you can tackle it. And if you're starting from scratch today, that's definitely not probably how you would do it. But can you go to the next slide? So we've been thinking about, ways we can replace this, because as I mentioned, it's really actually been great to see kind of the time series landscape evolve over even just the last few years. So there's a lot of good options out there. So, we're going to focus on Elasticsearch today, but there's things like InfluxDB and TimescaleDB and Postgres, and like the Thanos that is spun out of Prometheus and things like that. So a lot of great options out there. And some common themes with those is they have really good query languages. You can filter stuff out. You can do all these really great groupings and mathematical functions on stuff that just work out of the box, right? We don't, as the perfSONAR developers, don't necessarily want to be in the business of writing those, and quite frankly, we can't compete with those in terms of feature sets that a lot of these have. There's also been great development in terms of like visualization platforms that integrate then with these time series. So we have things like Grafana, Kibana, or any other ANAs that are out there in terms of being able to create really cool visualizations without necessarily being like a JavaScript developer or something like that. And then just standard features for doing backups and scaling. It's kind of wonky to say the least with Esmond today, the setups that we have, and there's a lot better options in some of the newer platforms that are out there, or older platforms that have evolved. And you also have the flexibility where you run these things now. If you do want to run storage in the cloud, if you're using some of these off-the-shelf things, it's pretty straightforward. Or you can still run it on-prem like you always do. But I think probably our biggest concern beyond feature set was just stability. I think Cassandra is still one of the main sources of issues, the way we have it installed on the user list. So we would like to kind of eliminate that. There's a maintainability burden that I kind of already alluded to for us. And then there's been a lot of other successes because, as I mentioned, pscheduler can write to more already, right? So people, if you're an advanced user, you don't necessarily have to be writing to just Esmond, and we have some power users that have figured out how to do that in the LAC community. That, like, for example, what Sean will be talking about later today, projects like NetSage, if you've heard of that, have done some really interesting work in these types of areas. So, it's kind of just a natural evolution, I think, to move away from Esmond. Sorry, next slide. I was trying to move it myself. Thank you. So as I mentioned, we kind of landed on this Elasticsearch, Logstash, Kibana, and Grafana stack. I talked about some of the other technologies out there. We looked at a number of things, and I think what's really great about the perfSONAR architecture is in choosing this, we're not saying any of those other ones are bad. In fact, I think it's awesome when I see people do things with some of those other technologies like Influx and the other ones. We just basically had to make a decision for ourselves. There's only kind of so much we can support directly, and we need some default set of tech essentially on our toolkits. We have pretty good experience kind of within the team already, just from on other projects and things like that, with kind of what's called the ELK stack or Elasticsearch specifically. Even we moved the perfSONAR lookup service to Elasticsearch like last year. So just in terms of kind of consolidating, tech stacks and things we have to support, we felt it kind of made sense for us, and, wouldn't necessarily close the door on anybody else who wanted to explore other options, right? And it really fits the data well. in terms of the types of searches you can do and things like that. A lot of the numbers are very metadata, we're very metadata rich in some ways. So there's a lot of different ways you can search and kind of join things and stuff like that. So can you go to the next slide, Daniel? So we kind of made this decision last year and we're reasonably far along. And then I think it was probably January or February, I think Elastic announced that they were switching up their licensing model. So Elastic has kind of always had this tiered model where the core of it was Apache 2.0, which is the same as perfSONAR. So that's great. They had some additional features that they were under what they called their basic license that were free, but they didn't necessarily change the source in all cases. And then they had a third tier, which was basically had to have a commercial license and stuff under that license, while interesting, was definitely not required for any of the stuff we needed to do in perfSONAR. So that was fine. So, in terms of licensing with the Apache license kind of at the center there, that worked really well for us. One of the things that was kind of, attractive about this option. Well, they switched to what's called the server-side public license last year. And this was in response to basically Amazon had essentially created a fork of Elastic that took the Apache bits, and then they re-implemented the features from the other two tiers, and then built an AWS service on top of this. And we're obviously making some money off of that. Elasticsearch decided strategically they didn't like that happening, so they switched to this SSLP or SSPL license. Sorry, and basically what that says is that anybody building a service with this also needs to, I think, inherit the SSPL and all that. So the SSPL is not an officially like OSI recognized open source license is the other thing. Things like MongoDB also use this. Depending on your organization, like I know, internally some of the perfSONAR partners have, run this by their legal departments and things. They're comfortable with us running this, and Elastic's not really like going after things like perfSONAR, but kind of as stewards of perfSONAR, we have to be, conscientious of the fact that, your organizations might make different determinations, and the lack of it being like an OSI recognized open source license is, kind of starts creating a gray area. So there's, risk mitigation we want to do there. So basically where we landed, could you go next slide? Is moving to what's called OpenSearch. So that's basically Amazon's solution. That's all Apache. They originally called it Open Distro by Elasticsearch, which was a mouthful. And after all this happened, they, for a bunch of reasons, have renamed it OpenSearch. So if at any point we say Elasticsearch, OpenSearch, or Open Distro, we probably are talking about the same thing. It just kind of makes things confusing. So they're trying to maintain backward compatibility with Elasticsearch as much as possible. Kind of our hope is, this will kind of be the default thing that installs for people that are familiar with Elastic. Like for example, yes, now we have a very large Elastic cluster and things like that. Or people that want to use Elastic, all the stuff we write will still be compatible with that. This is really if you kind of just install our default bundles and things like that, it'll be set up using OpenSearch. That way we can have as kind of open with license as possible, and also kind of still continue down the path that we were already on with this Elasticsearch type stuff. So yeah, that's something we've kind of had to go back and forth with over the past few months, and Daniel and Luan, who will be talking, have worked through a lot of that. Basically when you make moves like this, it's a lot of it's just like renaming properties and things like that, and really annoying stuff. It's not big technical things. It's like minutia that you just have to test and all that. And I'm sure Daniel will get into all that. So that's kind of where we landed on that front. Do you want to go next slide? So kind of taking all that, I just really want to quickly talk about all the different software pieces involved once we kind of make this change. I think one great thing about our architecture is that this isn't like a huge architectural shift. It's really just kind of swapping out one component, dropping another one in, and just getting all the packaging and things like that right. So what this diagram is trying to show is a very simplified version of the internals of pscheduler in terms of like writing a test and then sending it to an archiver. So those blue boxes are just showing there's a bunch of different archiver plugins. There's another one called Desmond Archiver, which most people use today that's not shown. and many others. But for the kind of the sake of the default setup that you'll get with the toolkit and things like that, it's gonna write to the HTTP, what we call the HTTP archiver. And this is just kind of a simple, HTTP post of essentially of the measurement results. We were trying to kind of minimize the number of components that people run. So like, out of the box, you're not required to run like a Kafka or RabbitMQ instance for a message bus. You could still do that if you so desire, and are familiar with how to set all that up and tweak configurations and all that. But we're going to try and keep it simple for default, just because that's easier to manage. So I should this HTTP archiver, and then next slide. Right. And so then when you zoom out a little bit, kind of the next step is this kind of archiving layer, which will consist of two pieces. So this log stash layer, and it says Elasticsearch there, but you can drop OpenSearch in there as well. It's basically the same concept. So it'll hit this log stash layer. What that'll do is do some formatting and allows us to bring in some more metadata. And in some ways, that might actually be the more significant change. Is it kind of just opens the door to bringing in some more information, so we can establish some of those relationships I was talking about, integrating with things. So for example, we can do a bunch of GeoIP lookups, which will help with like maybe building maps. It'll be customizable too. So if you have an internal inventory database or something like that, you could potentially modify the logstash pipeline to add some additional information about interfaces or something like that. So it provides a lot of flexibility there, and then stores it kind of in the OpenSearch/Elasticsearch backend. Next slide. And then once you have it stored, then our tool sets can start using it. So you'll see a box called Elmond. Again, Daniel will talk about that a little bit. That's the Elastic and Esmond kind of backward compatibility layer. So Esmond had this API that a lot of our tools use. I know others have written tools that use that API. It should be pretty feature complete with that API, at least in our testing it has been so far. So you can send your request to Elmond just like you would to Desmond, and it'll handle all the translation to the Elasticsearch backend, and things will still work. Outside of Elmond, though, we'll also have the ability to go straight to Elasticsearch, and you leverage the really nice query language that it has, and can do things with Microphone and Kibana. I think kind of the big takeaway here is for 5.0, we're really focused on swapping out that backend. And so if we do our jobs right, it may kind of sound funny, but things should be kind of boring on the front end, right? They should kind of look the same as they did before. In a lot of ways, you don't even notice. But there will actually be these really significant changes that have happened on the back end. And sorry if there's any background noise. So that's kind of our main goal. And then next slide. All right, and so we have all these kind of multiple kind of new parts, and we're swapping out this piece. As I mentioned, there's not a radical shift in the architecture. And a lot of these new components map really nicely to those existing bundles that I talked about in terms of like toolkit and test point and central management and all of that. And so this is kind of the point where I want to hand it off to Daniel and Luan to talk about some of that mapping and the work they've done to make that as seamless as possible. So Daniel, I'll hand it over to you.
Okay. Hello everyone. Can you hear me now? No. Hello? Yeah.
Yeah, I can hear you pretty good.
Okay. Yeah. Sorry. So hello, I'm Daniel from RMP in Brazil. I think Andy already introduced us. And we've been working the last couple of months on this new archive solution. Based on what Andy started, we've been working on moving from Elastic to Open Distro and all that thing, and probably we're gonna be still working to move again. So right now we already had available. We are working.
Daniel, just to jump in, it's very hard to hear you. Your volume is very low.
Okay. I'm just.
There's 6 or 8 comments in the chat window saying they're having problems hearing you.
Sorry. Yeah. Just stop me here for a second. Sorry about that. Can you hear me now? Better? It's better?
That's much better. Thank you.
Okay, sorry. Technical issues. Back to share my screen again. Okay, just here. Okay. So I was talking about, so again, my name is Daniel, I'm from RMP. and they already introduced us. We have been working the last couple of months with this new archive, and mainly based on what Andy started, we working on moving from Elastic to OpenDistro and doing all configurations. Right now we're working on the packaging. We already have available the RPM packages, so we can already test it on your CentOS 7. And the next step is the Debian packaging as well. We hopefully will be able we will available later this year. And right now today I'm going to show you how the installation occurs. It's quite similar to what it is right now you're used to do. So here I have so just talking. We already had available our RPM packages to install toolkits and central management. So I'm going to start here, show you guys how the installation of toolkit happens. And here I have a CentOS 7 machine, fresh machine. And the installation is quite simple. The first thing you need to do is to add the nightly repository. That is where our packages are right now. And if everything happens, sorry. Oh, I'm missing something. Okay. So there's where our packages are. And then you need to add also the EPL release, because we need some packages from there. If you have done the installation before, you're gonna see that nothing has changed much. I'm just gonna run a simple update here to make sure everything is fresh. It shouldn't take a while. All right. Yeah, it's just that. So if anyone are interested in testing it, we can also make sure we disponibilize some steps for you to test it. And the last step is just you install Persona Toolkit, and just simple like that. If you have done it before, it's the same way. It's gonna download a lot of things, and it takes a while to install everything, as you can see. Here I'm gonna just show some of the packages that are being installed. You can see here installing a bunch of packages related to OpenDistro and Elastic as well. The installation takes a little while to occur, mainly because Logstash and Elastic are pretty big packages. So while the installation is running, I'm going to talk a little bit more about the package structure. So the relation, how those new packages relate to each other. This is the relationship between packages right now in the 4.x version. And so not all packages are represented here, but just an overview of everything. So like Angie already told, Toolkit and Central Management both relies on the Almond package. And Almond is the one that you are trying to get rid of in this new version. So by doing that, we are now removing Cassandra from this tree. And so this new in this new architecture, Persona 5, we are replacing Almond with this new archive package. All green packages are still the same, so Persona packages, and these new white packages are the ones that I'm going to talk a little bit more about. But basically, archive relies on Elmond, Logstash, and also the OpenDistro for Elasticsearch. That is the one we are installing now, and maybe in the future it's gonna move for OpenSearch. And we also have an optional package, Kibana. We decided to make this package optional. So if you're interested in Kibana has a visualization tool, you can install it, and the Persona Kibana package is gonna make sure that everything's connected. So configure Kibana to connect to our OpenDistro installation, but it's optional so if you want just the normal use case for Persona, you can just install Toolkit or Central Management, and it's just gonna run the same. I'm gonna talk a little bit more about those 3 other packages that are new. The first one is Almond, like Andy mentioned before. The function of the Almond is just, it works like a translator. So it makes sure that anything that consumes the Almond API right now is going to still work with this new version. So it's basically, it's an API that translates Almond queries to Elastic and the results back to anyone that consuming it. It's just a Python 3 Flask application. And if you have Elastic instance already running in a different an external service or in the cloud, you can configure Elmond to connect to that instance as well. So here is the configuration. This is an example that we have in our test case. But if you just you can just change the configuration files and modify it to your needs. The next new package is the Persona Logstash. Like Andy mentioned already, Logstash it's a software to enrich the data to collect multiple source and join them in a way. So the Persona Logstash package is just a set of pipelines there that we are doing to make sure that all the results from Scalar are being saved in the correct format, the expected format for our case. So right now we have those pipelines. The first one is the input, just to that says where Logstash are expecting results from Pscaler. You can modify this as well. Just make sure that it is going. Everything is according to that. So the default value is localhost, and it runs on that 11,000 door there. For central management, we changed that to run on all IP addresses. So that works if you have, of course, the test point, external test points sending results. Those next pipelines just make sure that we're building Pscaler object, normalizing IP addresses, convert some durations to seconds, doing all the things that we are expecting to have in the template and in the end. Also, we are adding GeoIP information. So for all hosts that have those information, we are adding that. And then we process each type of task, removing, renaming some of those metadata fields there to make sure that everything's there. And at the end, it is just saved in the Pscaler template and send it to Elasticsearch or OpenDistro. And the same applies, the same that for Elmond applies to Logstash. So if you have Elastic instance running in a different server, you can also configure the Logstash variables there to connect to your OpenDistro Elastic external there. So that's also possible. And finally, the archive package. Archive is kind of like a bundle package. It installs everything that is related regarding to archiving and Persona. So both installs Elmond and Logstash that just talked about. Also installs OpenDistro and make sure that everything connects. Everything is connected together. So configures Elmond to connect to OpenDistro, also Logstash, and also configures security on OpenDistro and create certificates, self-signed certificates, and create user, give user permissions, limited some permissions there, and also configures ISM policy, that's index state management policy for Pscaler index. That's a policy for basically gives priorities, higher priority to newer results, and also make sure that some old results are removed from the OpenDistro after some age. So those are all the packages. I just a brief overview of all those new packages there. Just going back to this installation to see if we have done it yet. I think, yeah, it's complete. So nice. Just gonna show here that we have running. Okay. I'm gonna show the interface here. It's Oh, this is a spoiler for the list. So this is the interface, the toolkit web graphic interface that you are used to. As you can see, nothing changed that much. So it's pretty much the same. Those not gonna work, but okay. Here I can just run that persona archive, sorry. Yeah, this is the Almond interface, so it works, but there's no results there. But I'm gonna run a simple test here, so we have something there for us to see. Just a RTT task that's really fast. Should be. So basically, probably, yeah, just get back here and expect the results there. So if okay, so yeah, the results there. And if you look into the Almond, so Almond API, the results are the same that the Almond shows us. So for a user, nothing changed. It's just the background that are different. And also I had installed previously the central management. So just to make sure that we already had some results running. So this is running for last week also. And here are some of the meshes that we have. Those are our production test points here in RMP. And as you can see, the same thing, the same mesh. You can click and see results there. Just gonna reduce the time here. But it's the same thing that you're used to. So also I have here a query for the Almond. So I'm not sure if you can read this, but it's the same thing so that you're used to, like I said before. But you also have the possibility to add new visualization and to this environment right now that you have Elastic running. And about those new visualizations, Luan is going to talk about. So Luan is there.
Hello, everyone. Can you hear me? Okay, so I'm Luan, as Daniel said, and as Andy and Daniel have explained so far, the architectural exchange in the archive is transparent to final users. You can still do pretty much everything that you could do before. So let's move on to talk about two of the more interesting applications that we now have access to thanks to the new Elasticsearch archive. Kibana from the Elk stack is a powerful data analytics tool, and the web application Grafana for multi-source custom visualizations. So, as presented earlier by Andy, Kibana provides an intuitive graphical interface where users can work with the data and manage the Elasticsearch stack. As pointed by Daniel, the archive package sets up index state management policies that maintain the data with greater priority to the most recent task results in a hot warm delete architecture. Aside from that, Kibana's greater usefulness shines through when we want to have a closer look at a specific subset of the archive data. Elasticsearch stores data in the form of documents, and it has a strong focus on its search engine. When working in the discovery section, as we can see in Daniel's screen right now, we have a comprehensive look at the documents in the archive, the task results. In this tab, we can use the Kibana query language to filter the results with regards to any of the field attributes that were defined for the tasks. We're defining the Logstash pipeline. We can also select what fields will be highlighted and check what are the most common results for any of these fields. This makes Kibana a very powerful tool to analyze data on the fly, as well as to build visualizations and alerts to spot anomalies and watch the overall health of the stored perfSONAR task results. Now let's move on to the other one. Another perhaps more interesting software that we now have access to thanks to the new archive is Grafana that Andy introduced earlier. Grafana is a web application whose main focus is providing comprehensive tools to create custom data visualizations. Differently from Kibana that was specifically built to be used with Elasticsearch, Grafana can work with a multitude of databases in the form of data sources. This is made possible thanks to Grafana's openness that allows users to submit data source plugins, drastically extending Grafana's reach. Some of these plugins include Prometheus, InfluxDB, Elasticsearch, and many others, as you can see in Daniel's screen right now. The data from these sources can then be used to create custom visualizations in the form of dashboards. Dashboards are a group of one or more panels. You can see that dashboard has 4 panels, and each panel can have one or more data source. This means that basically in the same dashboard, we could have multiple panels with each panel displaying metrics from entirely different sets of data. Furthermore, in a more specific panel, we could have overlapping lines representing different perfSONAR tools, such as OWPing and TWPing, in order to directly compare the results. Perhaps even more impressively, it's possible to have multiple data sources providing metrics to the same panel. As an example, we could have a Prometheus line displaying throughput metrics from network switches and a perfSONAR line displaying throughput task results overlapping each other. This would allow us to directly compare the results and this would allow us to directly compare the results with a closer look, because they will be above each other and we can see when one goes one way and the other goes another. When you add to that the multitude of panel and data source plugins that are accessible with Grafana, you have a very powerful centralized hub for network operations. Even in the case that a very specific domain visualization that you want is necessary, in the worst case scenario, you could still build the plugin that you need for that visualization yourself. With that flexibility that is present in Grafana's huge ecosystem of plugins and extensions, the possibilities are virtually endless. And due to Grafana's wide adoption, a great deal of the issues that you could have when working with it are already answered by the community. So that's all for this part of the presentation. I'd like to hand it back to Andy or Daniel.
Yeah, I think I'm done also.
Okay, no, great. So thank you, Daniel and Luan, for showing all that stuff. So there's been some questions I know in chat as all of us have gone, and a lot of us have been answering them in chat, but I would actually just like to address some of them out loud for those of you who might not be following, and just, I guess, for the video. So I think the first one was that I saw was about the Elasticsearch configuration, and there was a question about whether it's just going to be a simple kind of one node cluster setup. So the answer to that is yes. Yeah, we're basically trying to keep it to a very simple Elastic config. It's one node. I think as Mark also pointed out in chat, kind of our bar is pretty low in terms of what we have right now is a little bit heavyweight. So our testing in terms of resource consumption and things like that have been very promising with Elastic. For those of you that have run Elastic at a large scale, obviously there's a lot of options in terms of multi-node clusters and things like that. For the scale of perfSONAR data that we're talking about, particularly when you're thinking like a toolkit or something like that, you don't need to get into that realm. So we're just, the default is just your basic single node cluster, and thus hopefully you don't have all the operational headaches you'd have with a much larger deployment. The other question I saw was Daniel had mentioned during the Logstash section about one of the things we have to do is normalize IP addresses. So this is actually something we have to do in Desmond as well. So if you run pschedule for a command line, or however you configure it, when you specify that source and destination, you can specify a DNS name, you can specify an IPv4 address, you can specify an IPv6 address. And that's for both the source and destination. So your source could be a DNS name, and your destination could be a v4 address, right? So when we store these, we keep what was given, obviously, because you might want to be able to search on that, but we also want to normalize things. So when you're searching for all the tests from a certain endpoint, it doesn't really matter what the person typed in at the command line, you can still find it. So we have to do some lookups and things like that. And, there's some interesting considerations, which, we've pretty much got down in terms of algorithms at this point for if, you give a DNS name and it has an A and a quad A record, which one do you use? And depending on what they gave for the destination, that may or may not change, right? Because if it's not capable of V6, for example, then you don't want to have one end try V6 and the other not, and stuff like that. So that's all we meant there. There's just, some pretty simple stuff we have to figure out there. And then there was also a comment about, I think when Daniel was running one of the system control commands, it still said Elasticsearch. So that's one of the fun things we've been dealing with is naming. Yeah. So we get, Amazon provides RPMs and Debian packages for that part. Open Distro is what it was called. And it was actually, like I said, Open Distro for Elasticsearch. So that Elasticsearch name was actually in a lot of stuff. Since they're moving to OpenSearch, and I think probably because of trademark issues and things like that, they're trying to get that Elasticsearch out. And so a lot of stuff is changing to OpenSearch. And so that's some of the stuff we're still working through. So we're hoping by final release to have that worked out. Anything else worth mentioning there, Daniel?
Yes. Yeah, just gonna, the same thing you just said. Yeah, also Open Distro relies on Logstash OSS and Elastic OSS. So in a way, they are moving away from that, but it's kind of messy right now. So something, the name is there.
And then I'm seeing a couple other questions come in. I'm going to jump to Tim's first before I go back to George's about migration. So one nice thing too about the Elastic setup is it actually has a built-in IPv address or IP address type. So when we store things like IPv6 addresses, we're not storing them as strings, so we don't need to worry as much about canonical names and things like that. It's basically an IPv6 address type, and it recognizes it as such. And so you can actually even do like subnet searches and stuff like that, which is really cool. So then this is a question I was expecting someone to ask. So the migration path for historical Esmond data. So right now, what we're looking at is unfortunately, so what most of the default setups are today is we have this script that cleans out old Esmond data. And I think it basically cleans out, the raw data after like 6 months and things like that. It's quite a bit of work to get that Esmond data out and all transferred over, especially given that, some of the hosts are kind of underutilized or don't have super powerful hardware and would have to run all the Cassandra stuff and the Elastic stuff at the same time. And if you have a beefy host, maybe you'd have the memory for it, but if you're running like kind of minimum system requirements, probably not so much. So basically our current plan is when we release 5.0, we'll have toolkits and things auto update, and obviously we won't delete any of the old Esmond data or anything like that. It'll still be there on disk if you want to get at it, and we'll provide instructions for getting at that data and things like that. For central management, obviously that's going to, in theory, be a much bigger set of data. And so we don't want to auto update those for people. And the other, obviously, more important piece is you will have multiple testers writing into it. You may or may not control all those testers running into it, so they may not all be upgrading at the same time, right? So we're basically not going to auto update that, and we'll have the steps for kind of manually migrating over so people can kind of do that at their own schedule. Also a good reminder too is you can write to multiple archives at the same time. So, we'll try and map out some different migration paths for people, but that might be one thing is have for a while, your various nodes write both places that can and give you kind of some time to transition over. So I think that's some of the big work left to be done is kind of writing those documents and help people kind of through that process. So, hopefully that answers questions on that. And I'll pause because I know it takes time to type. So, yeah. Okay. So in terms of timeline, when this is expected to be released, I don't think realistically, obviously the final release won't be out till sometime probably in early 2022. We're still working on beta schedule. We're getting to Thanksgiving holiday time, so I don't know that we'll have it out by the end of the calendar year, but hopefully very early when we get back, we will. If not sooner. As Luan and Daniel showed, we're pretty close. It's just a lot of that naming and documentation stuff and various testing we want to get cleaned up before we release it out into the wild. So that's our current thinking. And a bunch of support, yes, that will continue for this. So Daniel and Luan, I think he briefly mentioned it, has been working on the packaging for that. Mark will be talking in about 15 minutes too about kind of all our OS support on that front, but all that definitely applies here. Yep. So we're planning to have Debian and Ubuntu packages for all this as well. And we've already kind of made good progress on that front too. So. Anything else? Yeah, so that's a good question on the ingest nodes. They definitely do seem to be migrating stuff there. So we'll have to wait and see on what happens. I mean, I think the reasoning for doing that is that puts everything under their same license as everything else, because the Logstash is still an Apache piece. They've been doing some weird stuff too there with checking what's on the other end, which OpenSearch has. Does OpenSearch, Dana, I don't remember, does OpenSearch actually have their own fork of Logstash, or is it just a plugin that they've written?
No, they relies on Logstash OSS, the open source version. Right now, I'm not sure if they're gonna change that, but I think there are some problems with licensing checking with the version, if I remember correctly.
Right. So yeah, so that's why we need the different plugin and stuff.
Yeah.
Yeah, there's been some fun stuff going on that front. So
yeah. So yeah, we also have to install a kind of old version. Not that old, but you can install the newest.
May I comment, Andy? So they have implemented an output plugin, the one that receives the data and sent to Elasticsearch, and they have a container of Logstash using the OpenSearch plugin. So that's how they are circumventing it officially right now, but maybe things will change further.
Yep. Yeah, but I think, Paul, to your original point too, long term, I have not seen any indication that they're just gonna completely wipe their hands of Logstash or anything like that. But with all these vendors, there's various risks, so we'll have to wait and see. And then in terms of system requirement changes, right now we're not planning any changes to the base requirements as they stand now for the full toolkit install. So